And this is my first time to be the session chair, so I may be more nervous than the speaker. Okay, anyway, there are 5 papers in this session, and the first presentation is entitled VirtualTouch, a finger glove to simulate touch screen command. The authors are from National Jiaotong University, and the presentation will be given by Jun-Zhe Wang. So welcome to Jun-Zhe Wang.
Good afternoon, everyone. Thanks for being here. I'm Jun-Zhe Wang, a PhD student from National Jiaotong University. The subject of my presentation today is VirtualTouch, a finger glove to simulate touch screen commands. My presentation will be divided into 3 parts. First, I will take a few minutes to introduce the research motivation and the research purpose. And second, I will introduce our design of the VirtualTouch system. And finally, I will conclude this paper. And recently, the advance of MEMS technology has made the sensor-based human motion tracking possible. Hand gesture capturing is one of it, and hand gesture can be captured by wearable sensor globe and cameras. Wearing a sensor globe to control devices has become an intuitive human-computer interface in many fields, including robotic control and computer graphics. Touch screen has become more and more popular in many end devices, such as smartphones and iPad. Many of these devices using MultiTouch command as their input command, but although touching a smartphone is handy, but this is not suitable for large screen environment. And this is not available in large screen environment. So in this paper, we are interested in capture hand gestures to interact with large screens. So we design a glove-shaped input device called VirtualTouch to capture hand gestures for interacting with large screens. More specifically, we simulate the screen touching operations without actually touching the screen. This figure shows the scenario of how to use VirtualTouch glove. In the left, user wear the VirtualTouch glove. He can perform some MultiTouch operations in the large screen environment, such as he can drag or flick these maple leaf pictures, or he can rotate the maple leaf picture counterclockwise, and he can run the maple leaf picture, bring the picture out. So in this paper, we implemented the whole MultiTouch operations specified by Windows 7. The systems of VirtualTouch works as follows. First, a user wear the glove and the glove will sense his hand gestures and extracts the hand model parameters. Then the glove will transmit the parameters to a USB dongle attached to a computer. Then the dongle will translate the hand parameters into location of touch points. Finally, the dongle provides the location to Windows 7 operating system. Now I will introduce the design of a VirtualTouch. This is the system architecture. VirtualTouch is a global shift input device. This is the globe. It consists of a finger bending sensor and a MCU with a wireless module and a triaxial accelerometer and some buttons. And these sensor readings will be transmitted to the USB dongle wirelessly. This USB dongle is connected to a PC running Windows 7 operating system, and the USB dongle will implement our touch simulation algorithms. Now I want to introduce the software architecture of VirtualTouch. The software architecture can be divided into 3 parts based on the different hardware components. In the bottom is the software architecture of a sensing globe. The motion analysis module will process the readings from bending sensor and the accelerometer and the clicking button and the mode switching button. Then he will calculate the hand model parameters and transmit it to the USB dongle. And upon receiving the hand parameter, the OS interface will perform some conversions to convert these parameters to the locations of touch points, and he will use the standard USB HID protocol to communicate with the PC running Windows 7. We will focus on the motion analysis and the OS interface, and the software architecture of Windows 7 are not a part of this research. So now I want to introduce the motion analysis module. The motion analysis module processes the sensor readings and get and calculate the hand model parameters. In the hand model parameters, the alpha of t is the angle between the thumb and the index finger at time t. It is from the bending sensor reading, and the theta x of t is the angle between gravity g and the x-axis at time t, and theta y of t and the theta z of t is similarly. And the status of buttons is processed by the hand model parameters. This is this part. Now I want to introduce the OS interface. Here, the OS interface in the USB dongle conducts the simulation of touch commands. Since Windows 7 expects touch panel inputs, so some conversions of the hand model parameters are needed. This can be done in two phases. The first phase is to recognize gestures, and the second phase is to convert the hand model parameters to the location of touch points. And these gesture being captures might be quite similar, so we need a mechanism to know the exact intention of the users. So we let the VirtualTouch operates in one of the following modes. The first mode is standby. It simply does nothing. And the second mode is mouse operation. It performs the cursor moving and clicking functions. And the third mode is single touch mode. It performs the single touch operations such as dragging, scrolling, and flicking. The fourth mode performs the MultiTouch operations, which includes rotation and running functions. The mode switching function can be done by one long click the button 0. This is button 0. And the second phase of OS interface is convention phase. Here, the hand model parameters are converted to locations of touch points on a virtual screen to simulate touch panel inputs. It is operated in one of the following modes, which is mouse operation, single touch, and MultiTouch. The mouse operation, the first function of a mouse operation is cursor moving. When this mode is selected and the user tilts his hand left, and we will update the location of a cursor XY to the X minus delta y. The delta is the predefined incremental parameters. And when the user tilts his hand up, we will update the location of the cursor to x, y minus delta. And the right cursor moving and the down cursor moving is operated in a similar way. Now here I introduce the clicking function of mouse operation. The short click is implemented by one short click button 1, and the double click is implemented by two short click button 1, and the right click is implemented by one long click of button 1. When a single touch mode is switched, it will be one of the following operations, which is dragging, scrolling, and flicking. VirtualTouch consider this operation, this gesture similar to a cursor moving gesture. So the dragging is a horizontal move, and the scrolling is a vertical move, and the flicking is a large-scale dragging or scrolling. So the flicking function is a large-scale horizontal move in here. This is left flicking. We update the touch points, the location of touch points to x minus 2 times delta and y. And the right flicking is similar, and the up flicking is similar, and the down flicking is similar. Now I will introduce the MultiTouch operations, the rotation mode. While the user tilts his hand left or right, he will rotate angle with rotate angle around the z-axis. So using the polar coordinator system, we can get the 2 points, the 2 MultiTouch points. This is the red points is a MultiTouch points, which is x plus gamma and y, and x prime, y prime. And these 2 points can be derived by calculating the polar coordinate by the theta. The theta is the angle rotated by the user. And now I want to introduce the running function. When the user runs his finger about alpha angle, and the running distance can be derived by the alpha t. So the touch points will be, a series of touch points can be derived based on the distance calculated from alpha t. And now I want to introduce the USB HID module and the Windows 7 module in the software architecture. And the USB HID module will receive the location of the virtual screens from the OS interface, and he will communicate with the Windows 7 operating system using the standard USB HID protocol. And the Windows 7 will recognize the XY location by the HID driver. This part is not a part of our system. And finally, I'd like to draw the following conclusions. In this paper, we simulate MultiTouch by global shift input devices for interaction with large screens. And we have developed a global shift input device called VirtualTouch that is equipped with a bending sensor and accelerometer. And we have proposed a scheme to simulate the touch commands via virtual screen mechanism. In the future work, we wish to turn to other operating systems and with more gestures. And that's all for my presentation. Thank you.